Let's look at some additional aspects of radical axis. We have already seen it in our previous session. Let's continue. Now let's draw some circles. Okay, so we know there will be a radical axis somewhere here. Let's combine them. So these are the three possibilities. You have two circles not touching each other in any way or intersecting each other, and the radical axis is somewhere in between these two circles. Then you have another situation where the circles are intersecting each other at 2 points, and the radical axis in this case would pass through both these two intersections. And the last is when the circles are just touching at one point and the radical axis passes through that point. So in this case, C1p square minus R1 square is equal to C2p square minus R2 square. Here the various variables have usual meanings. So C1 is the center of first circle and P is a point on this radical axis. C2 is the center of the second circle. R1 and R2 are the radius of the two circles. Okay, in this particular case, what happens? C1p square minus R1 square is equal to C2p square minus R2 square. But here what happens is C1p and C2p are the radius of respective circles. So therefore C1p I can replace it with R1 square minus R1 square, R2 square minus R2 square. So which implies 0 equal to 0. So which means the radical axis is the common chord of the two circles, and in this case radical axis is the tangent, the common tangent of the two circles. Okay, now let's look at another interesting aspect. What if we are talking of three circles, right? So let's look at another very interesting aspect. The radical axis of three circles which are non-collinear, taken in pairs, are concurrent. So let's say this is S1, S2, S3, three circles. Then in that case, remember, as far as the power of a point is concerned, we can get it just by subtracting. So S1 is, let's say, x square plus y square plus 2g1x plus 2f1y plus c1 equal to 0. S2 is x square plus y square plus 2g2x plus 2f2y plus c2 equal to 0. And S3 is square plus y square plus 2g3x plus 2f3y c3 equal to 0. Let's take S1 and S2. So S1 minus S2 would give us what? Let's subtract it here itself. X square y square gets cancelled. 2g1 minus g2 x plus 2f1 minus f2 y plus C1 minus C2 equal to 0. This is nothing but the radical axis between S1 and S2. Similarly, so this is S1 minus S2. Similarly, between S2 and S3 would be what? S2 minus S3. So that would be again x square, y square gets cancelled. G2 minus G3 x plus 2 times F2 minus F3 y plus C2 minus C3 equal to 0. So this will be S2 minus S3. And finally, S3 and S1. So S3 minus S1 would be 2 G3 minus G1 x plus 2 F3 minus F1 y plus C3 minus C1 equal to 0. Now again, if you look at the diagram, you will find that there is a point at which all the three radical axes intersect. So point of concurrence or the point of common intersection of the radical axis is called the radical center. So this point, the middle, is the radical center. So R is radical center, and this is S3 minus S1. Now, if R is outside, which is what it is here, outside S1, S2 and S3, then the length of the tangents from R to S1, S2, S3 are equal. Okay. Another interesting thing. S equal to 0. This is a circle. Right. L equal to 0. This is a line. Then S plus lambda L equal to 0 is a circle. Let's see. Let's say S is x square plus y square plus 2gx plus 2fy plus c equal to 0. L is let's say ax plus by plus c equal to 0. Let's say c1, a different c, different value of c. Now s plus lambda, let us say, is 1. So let's say lambda is equal to 1. Then s plus l would be x square plus y square plus 2g plus a plus 2f plus b plus c1 plus c, or c plus c1 equal to 0. This is again a circle. So a point P satisfies S equal to 0 and L equal to 0, means it satisfies S plus lambda L equal to 0. This means that S plus lambda L equal to 0 is a circle passing through the intersection of S equal to 0, the circle, and L equal to 0, the line. Now let's say similarly S1 equal to 0 is a circle, S2 equal to 0 is a circle, then S1 plus S2 equal to 0 where lambda is not equal to minus 1 is also a circle. Okay, let's see. Let S1 be x square plus y square plus 2g1x plus 2f1y plus c1 equal to 0. S2 is, let's say, x square plus y square plus 2g2x plus 2f2y plus c2 equal to 0. So here, as you can see, S1 plus S2, sorry, this should be lambda S2, missed that. So let's say lambda equal to 1. So S1 plus S2 would be 2x square plus 2y square plus 2g1 plus g2x plus 2f1 plus f2y plus c1 plus c2, which is a circle. So the coefficients of x square and y square, if they are equal, that's well enough, because we can divide the entire equation by 2 to get coefficient as 1. Now, if lambda is equal to minus 1, then what happens? If lambda equal to minus 1, this becomes S1 minus S2. And you notice, immediately x square and y square disappear. And we are left with 2g1 minus g2x plus 2f1 minus f2y plus c1 minus c2 equal to 0. Now, this is not a circle. So, S1 plus lambda S2 equal to 0 is a circle passing through the intersection of S1 and S2. That's enough. Bye for now.